HCI.
All right, it's 2 o'clock, so let's get started. So just a few announcements. Homework 2, in fact, is out. It was posted, I think, early this morning. So go ahead and get started on that because the first part's due on Sunday. Solutions homework 1 is also posted on Blackboard, so check those out if you actually did some of the homework questions. And quiz 4 is out tomorrow, and also due on Saturday, as usual. So any questions before we start? About any of the material, anything? No questions? Okay. So, what was the major thing we talked about in lecture last week?
NFAs?
Yeah, NFAs, but what were they trying to solve for us? Yeah, these things called regular expressions, right? So what is a regular expression? How did we define those? Is it something related to building small pieces and then building larger ones? Something like that? How did we start defining regular expressions?
Regular languages make regular expressions.
Well, that's the result we came up with, but how did we define a regular expression?
Is it an expression accepted by a DFA?
That's a regular language, but what's a regular expression?
DFAs combine.
Guys? Don't make me frustrated. How did we actually define regular expressions in class last week? Something about really small things and then building larger ones. So I'll help you guys out. So empty set is a regular expression. What are some other ones that are really simple? Epsilon, yeah. And a single character A for all A and so we were always working over some alphabet, so we just say a single letter is regular expression. But how do I form larger ones from the smaller ones?
Star?
Yeah, so that was one of them. So oh no, that was the last one. So the last one was if we have a regular expression, then we form the star of that. That's also a regular expression. So I got to say where R1 is a regex. But what were some of the other ones? Concatenation, yeah. So I have to have, remember I have to have 2 of them for concatenation. So R1, and this symbol just means concatenation for regexes. So the concatenation of those 2 where R1, R2 are regexes. All right. But what was the 4th one? Yeah, union, yeah. So if I have 2 regular expressions, form the union. Okay. So it's an inductive proof. Inductive definition. We have small regular expressions, but we can build larger ones from the smaller ones. Okay. And so why did we use regular expressions? Why do we care about those? Well, it seems like we can actually describe languages much easier than just using a machine model where we're not exactly sure if it accepts the right thing that we want, right? Regular expressions really gives us a lot more descriptive power here. So what were the results that we showed in class in terms of regular expressions? It was actually hinted at earlier. What languages do they recognize? The regular languages, right? So the way we show that is we can convert something that represents a regular language into a regular expression and the other way around, right? And therefore they would recognize the exact same languages as regular languages. So the thing that we used to represent a regular language was an NFA, converted to a regex, and the other way around. So let's do those 2 conversions via those exercises. So I have this, not be NFA to regex, it should be regex to NFA. So I have this regular expression here, and I want to build an NFA for it. So what do you think would be a good strategy when you see a regular expression like this to make an NFA?
I'll look at it in a way of like priorities, like parentheses first.
So there's some kind of ordering as to what order to do. So it seems like the star is going to be applied last, right? What do you think is going to be applied second to last? Union, right? And then third to last? Concatenation, right? And so what would happen before the concatenation? What things do I need to recognize first? Well, if I recognize just the single character A or the single character B, could I do this whole expression? Well, with these three recursive things. Yeah, I certainly could. I can then do AA, then BA, then reunion, then the star. So we start with smaller things, then we build larger things. So can I recognize just a single character A? Can I do that with an NFA? Yeah, how would I do that? Yeah, so just a single transition on the symbol A. So I'm just going to have an NFA, very simple, just two states, and just a single transition. And note, it was so much easier to use an NFA here because I don't need to define any other transitions. Well, they are defined, but I don't need to draw them. So it's a lot easier to do this. And I think I can do the single character B very, very similarly, right? So I'm going to do that one over here. Just a single character B. And we can certainly make NFAs for those. Okay, so now, as we just discussed, we need to do concatenation next. So let's just say I wanted to do AA. Could I make an NFA to do that? Yeah, how would I do it? So what you're saying is to do this, right? Yeah. Is this the technique I should use? No, what's the technique that I should use? Okay. So the idea is, remember, what this represents is that this is not two characters here. These are two regular expressions that only are a single character, but they are regular expressions themselves. So I'm thinking, how do I concatenate regular expressions, the NFAs for regular expressions together? So essentially, what I need to do is have two copies of this NFA down here. So I have two copies of this NFA. And then how do I concatenate these NFAs together? Epsilon transition from where to where? The final state of the first one to where? Start state of the second one. Good. Just like that. Is there something I'm forgetting? Yeah, I can't make this one final. Good. Because I don't want to recognize just a single character, right? I want two A's. Okay? And I think I can do BA very similarly. So I'm going to do that right here. So I'm going to have a B here, epsilon transition to A, and then okay? Cool. So what was the next operator I need to do? Union, yeah. So it's the union of these two. So let's just do AA union BA. And so I think if I'm going to be doing union, I should have a copy of the NFA for AA and a copy of the NFA for BA. Oh, and I have those right there. So I'm just going to copy them straight down. Oh, that's not B, sorry. If I make a mistake, please tell me. I hate making mistakes. All right. Well, how do I recognize the union of these two NFAs? Yeah, we need a new start state and an epsilon transition to both of the original start states. Good. So that's just the construction we saw in class. So I'm not going to do that red. I'm going to do it in the same color. new start state and epsilon transition to the old start states. Because I can choose either one to do. Okay? Cool. So, am I done with the whole problem? I need to do the star operation. So, for the interest of time, I'm not going to copy this again because it's getting quite big, so I'm going to do it in place. So I'm going to try to recognize what I just did star. So how do I do that with an NFA?
Epsilon from the final state.
So one may think, well, I can just come from these start states back to here. Is there a problem with that? Yeah, I need to make the start state final, and I may accept strings that I didn't intend to before. So how do I fix that? Yes, I need a new start state. Good. So I need a new start state. Is it final or non-final? Yeah, it better be final. Why does the start state have to be final? I have to accept the empty string. Yeah. Good. So I'm going to have a new start state, epsilon to the old start state. And from these final states, I'm going to come back to this final state. Good. Okay. So the whole idea of converting a regex into an NFA is just, can I make the really simple things? Then I'm going to start building larger and larger NFAs until I get the whole thing. And then we just take note of what is the last operator I need to do, what's the next one, and all that stuff. And then we just combine them. It's all just combining. Okay. Any questions about how we were able to do that? Yeah. It may work here, but suppose I had an NFA. Oh, actually, let's make it a DFA. Arbitrary black box DFA right here. And let's say it has two final states. What string do we always know is in the star of any language? The empty string, right? So since this is a DFA, this start state has to be final, right? Because I have to accept the empty string. But suppose I had a non-empty transition to a non-final state in the middle. So like A and that here. I accept the string AA now, but I didn't before because it was a DFA. So I may accept strings that I don't intend to otherwise. Here it's okay because the epsilon transitions don't go, we only have epsilon transitions out, but I want this to work for every single NFA. Okay? Yeah.
So just, I want clarification. So when you concatenate AA, why do you have to do the epsilon to the second name?
Yeah, because I could make two transitions back to back AA, but I'm not thinking of these as characters. I'm thinking of them as regular expressions. So I'm thinking of this as a regular expression A, regular expression A. Then how do I concatenate two NFAs together? That's the reason. It's just making sure that that this works for every single NFA. Sorry, for every regular expression.
But could you simplify it later? Or
I could, but I don't want to be clever about this. I want this to be absolutely algorithmic, and I don't have to think about it. Yeah. See, like I didn't have to think about any of this other than just knowing how to do the construction. But other than that, I don't have to do any simplification. Any questions?
You could have combine the final states, right?
I could, but I want this to be algorithmic. Yeah. So if you were asked to make a smaller NFA, you could, but we're not asked.
for the most part, that's how our answer would be.
Yep, that's the answer. Yep. But the most important thing is understanding how we were able to do this and why we're doing it this way.
If you're unsure, would it work just to add an extra start state?
You always have the start state.
So it doesn't matter what.
Always. It'll never be incorrect. But making this the new start state with being final, that may be incorrect. Okay. Any other questions? This is good. Okay. So now let's do the other way, converting an NFA into a regular expression. So this was this GNFA thing that we were talking about. What's a GNFA? Yeah, this generalized NFA thing. So what makes it generalized? Have what on the transition? It has more transitions, but what do the transitions have on it? Regular expressions, right? Instead of just a single character, I have regular expressions on the transition. So, what was the idea about converting an NFA to a regex? What was the idea that we came up with? Yeah, so something about ripping states out and then hopefully ending up with a situation like this, where I have a single transition to a final state, labeled with some regular expression because we have regular expressions on the transitions, and then we can just say, okay, the regular expression we want is just R, right? Because there's no other way to accept at that point. But how do we even get to this situation? Well, I gotta rip states out, but what else do I have to guarantee? One start state and one final state. That'll certainly help, but what else do I need to guarantee about them? About that start and final state?
You can't transition back to the start state.
Yeah, so there's no way to enter the start state. So like if I had a situation like this, then I'm toast, right? Because there's a way to get back into the start state, and I don't want that. What about the final state?
No way to leave.
No way to leave either. So how do I fix this NFA because it has a transition coming into the start state, a transition out of the final state, so how do I fix this? I better add some more states. I better add a new start state and a new final state. Because I want to end up with a situation like this, and so I can't have anything coming in. Because that would change how I can simplify things. So it's like, it's basically you're trying to force all of the simplification to happen outside of you. You're the start state, and then once the dust settles and everything, you have one transition out of it. So it's like you're not even involved in the process. Okay, so I want to convert this to a GNFA. So the suggestion is let's make a new start state. So I'm going to call it QS for start. And I'm going to leave the rest of the machine the same. And as we suggested, we better add a new final state. So QF, I'm going to call it to be final. And all of the existing transitions are going to stay there. No difference. Well, there is a difference, but not the same thing. And I think we're not. Oh, okay. Well, how do I hook up this new start state and this new final state to it? Yeah, epsilon transition. So QS goes to where? The original start state. Good. So it comes here. What about anything involving the final state that we just made? What's going to hit it? Well, I don't want to change the language, so I think Q1 better go to QF on epsilon, because if I'm going to accept, I was going to be in Q1 before, and I still need a way to accept, so I should come from Q1. Okay. Nice. So now we have a start state that has nothing coming in, a final state that has nothing coming out, and so we're all good now. But note something very important. What are these labels now? They're regular expressions. They're not a character anymore. Even though they're drawn the same, they're regular expressions, not characters. And so that'll be helpful when we start simplifying this. Okay, so when we started ripping states out, does it matter what state I rip out? If it's not the start or final state? No, it doesn't matter. So, any choice? Q0. Perfectly fine choice. So let's rip out Q0. So all the other states are going to stay put. Because all the transitions not involving Q0 are not going to change. Oh, that's not the point. So that came from Q0, those involve Q0, I think that's it. So just for simplification, when I say A comma B here, it means A or B. I can take either of those. So how do I represent or with respect to regular expressions? Union, yeah. So I'm gonna simplify my life a little bit by writing A union B on the transition instead of comma here. Because I really want to think of these as regular expressions, not vectors. But I think all of the other transitions involve Q0, and it looks like that. So what's the method for when we rip out a state? What am I gonna do? Yeah, I'm gonna be adding transitions. So how do I find out what transitions I'm gonna add? I gotta look at every way in. If there's a loop, I look at the loop. And every way out, then make all the transitions combining all of those. So what are the ways that I can enter Q0 from somewhere else? QS, I can see, Q1, I can see, and that's it. So I'm gonna make a list in Q0. And so I know that's QS and Q1. Where can I go to from Q0? To somewhere else. The Q1 and Q2 it looks like. So out Q0 is Q1, Q2. So how many transitions do you think I'm going to add here? 4 it looks like. Every way in times every way out, that's 4 to me. So let's start adding them. Let's do QS to Q1 first. So QS, I gotta look at the ways into Q0, then back out to Q1 from Q0. So how can I get from QS to Q0? Epsilon, that's the only way there. So epsilon. I could have chosen not to write anything, but it doesn't matter here. Is there a loop on Q0? No, there's no loop on Q0, so I ignore that part. How do I get from Q0 to Q1? Simple B, yeah. So I'm going to add that concatenated. So what is epsilon B? B. Just B. So now I'm going to make the transition from QS directly to Q1 on B only. All right, so we took care of that one. Let's do QS to Q2. So QS into Q0, out of it into Q2. So I think QS to Q0 is still epsilon. So I'm going to write that again. Q0 still doesn't have a loop, so don't worry about that. Q0 to Q2, how do I get there? So just a simple A, yeah. So, and likewise, epsilon A is just A. Now I've got to make a transition from S to 2 on A. All right. Let's do the other ones. Q1 to Q1. So Q1 into Q0, back out to Q1. How does Q1 get to Q0? A, so I'm going to write that down. Q0 back out to Q1. B, yeah. So it's going to be A, B. So it says Q1 to Q1. So what is it? What am I going to have up here? Self loop, yeah, on state Q1, on AB. Okay. Got one more. Q1 to Q2. So Q1 into Q0, back out to Q2. So what is this transition going to be? AA, right. So A to get to Q0, no loop, A back out. So that's going to be AA. So it's from 1 to 2. And no, I don't have a transition yet, so I'm going to add one. directly there on A. Okay. Good so far? Now what state to remove? Any choice? Q1's perfectly good. So let's rip out Q1. So again, all the other states are going to stay put. So Q2's here, QF is over here. QS is Q2 directly on A. I think, oh, and this. All the other transitions involve Q1. Okay, so what are all the ways into Q1 from somewhere else? Well, let's see, S goes directly there. Anywhere else? The Q2 goes directly there, and that's it. So into Q1, I have QS and Q2. Then out Q1. We're going to get to from Q1 to somewhere else. I can go to Q2 or to QF. So Q2. Yeah. Well, I'm removing Q1, so it's irrelevant whether I'm coming back to Q1. I'm going to be considering it, but in terms of adding transitions, it's not going to be there. So. Any other questions? Yeah.
There's also the Q1
On what?
in the Q1.
That was the question earlier. I'm not worried about that because I'm ripping the state out, but I will be considering it when I go into Q1 and possibly could stay there. I'm simulating as if I went into that state. Any other questions? Okay. So let's do the first one, QS, Q2. QS into Q1, back up to Q2. So how do I get from S to 1 in this one? A B? Good. I'll write that down. Do I have a loop on Q1 now? Yes, I do. And it's AB. So how do I represent the loop here? Star. AB star, because I can take that loop 0 or more times. Well, that's just star. So AB star. Okay. How do I get from 1 to 2? AA, good. So, AA. Well, we got to make a transition from S to 2. Oh, wait, I already have a transition there. So what do? I do union, right? Because I can take this transition or this transition corresponding to this regular expression. Okay. So I'm going to make A union this one. B AB star. Okay. So it's just combining the regular expressions together. Let's do S to F. So S to 1, how do I get there? B, same thing as before. So I have B. I still have the loop on Q1, so I'm going to write AB star again. And how do I get from 1 to F? Epsilon. So there it is. So now I've got to make a transition directly from S to F. And I don't have one already, so that's good. So I make one directly there. On B, A, B, star. Okay. Yeah. Oh, that's another question. Let's do 2 to 2. So Q2 into Q1, out to Q2. Q2 to Q1, how do I get there? A union B, all right. So I'm going to put these in parentheses because it's union here. Q1 still has the loop, so I'm going to have AB star again. And don't worry, I'll put identifiers on these so we don't have to repeat everything. So self loop on Q1. Now I got to go back out to Q2. So how do I get from 1 to 2? It looks like an AA to me. So, AA. And, oh, so what's going to be drawn on here? Looks like a self loop again because I'm going from 2 to 2. Oh, wait, I already have one there. It's union again. So on the self loop, I'm going to have B union this guy. A union B. You know what? I'll just put an identifier on this. I'm going to call it R1. So this is going to be instead B union R1. So I don't want to have to write that again. Okay. 2 to F. So Q2 into Q1, back up to QF. Q2 to Q1, that's still going to be A union B. Q1 loop is still going to be A B star. And then now we got to think Q1 to QF. How do we get there? Epsilon again. Well, there it is. And I'm going to call this R2. I guess I should have named the other ones, but and this is from 2 to F. Nice. So any choice of state to rip out next? There's only one, right? So now I have to rip out group 2. And we'll do that. So I'm going to give these names too. So sorry for the names in the order right here. So this is just A union R3. And this one is just R4. So I don't want to have to write it. Okay. And then since I wrote Q2 out, I only have QS and QF left. QS, QF, which is final. And so what do you think is going to be the label on S to F now? Well, I have R4 already there. That's the existing label, but what am I going to put on the other part, the other path? Well, there's only one way in and one way out, so we don't have much choice there. So I think from S to Q2 is A union R3. So I'm going to call it the label is going to be A union R3. Then I can take that self loop on Q2 as many times as I like, which is B union R1. It's B union R1 star. And then the path from 2 to F is R2. I'm going to call this R5. So what is the final label going to be? R4 union R5. Because I could have taken the R4 path or the R5 path. Okay. Is this the regular expression that I wanted? Careful. Is this the regular expression? I'll give you a hint. Is this the regular expression that I wanted? No, what is it? It's the GNFA. What's the regular expression that I wanted? The thing on the transition, right? So the final thing is to write the regex is R4 union R5. I know it seems trivial, but the important thing here is to note this is not a regular expression. This is a regular expression. Just knowing what's the difference between these different models that we have is the most important thing. Okay? Anyone confused as to how we were able to rip states out and everything? Because we're going to have a larger example next. Okay, so let's do a slightly larger example. Quote unquote, slightly. Very large. So what is this thing? It has 4 states. I want to convert this NFA into a regular expression again. So what's the first step I need to do again? I got to convert it to a GNFA. So how do I do that? New start state and new final state. So I'm going to convert this to a GNFA first. So we've got to add a new start state, QS. And the rest of the machine stays put. And a new final state QF. Epsilon from S to 0. The rest of the machine is the same. I'm going to make this A union B because I want the union there. A epsilon B. And as always, I need to connect all the old final states via epsilon transitions to QF. So epsilon here, epsilon here. Okay. It's just the same setup as we did last time. All right, let's start ripping states. Any choice? 3. So, of course I could rip out any state, but is there any particular reason 3 was chosen?
3 only had epsilon transition.
Yeah, there's only one way in, one way out. So I'm only going to add one transition. That makes it a lot easier. But we can rip them out in any order. Just minimizing our pain. Life lessons by Ryan. So I'm going to rip out Q3. So rip Q3. And all the rest of the machine's the same. QS, Q0, Q1, Q2, all stay there. QF is still there. Epsilon in, B, B, A, epsilon, A unit B, and I think those are the only transitions. Only. All right, so now I'm going to be adding exactly one transition, thank goodness. From where to where? To the F, so I don't have one already, so I'm going to add one. So what's the label going to be, do you think? The B star, right? Because it's just epsilon, B star concatenated with epsilon, which is just B star. Good. That was a lot easier. That was very easy. Okay, so next state. 2 them in backwards order, right? So let's do, so this one's a little less non-trivial. So, a little more non-trivial. Q0, Q1, QF. All the old transitions stay there. B, B, A, epsilon. And every other one involves Q2. Yes. So what are all the ways into Q2 from somewhere else? It looks like only Q0 to me. Okay, that's good. So in Q2 is only Q0. That makes it easier for me. What about the ways out? Where can Q2 go to? 1 and F, it looks like. So I'm going to be adding 2 transitions. Let's do Q0 to Q1 first. So Q0 directly to Q1. So 0 to 2, what do I read? Just the regular expression A. Q1, just, oh yeah, Q2. Does Q2 have a loop? Yeah, so what is going to be next in this label? A star, yeah, because I can follow that loop as many times as I like. And then now 2 back to 1. What do I have? It looks like A union B to me. So I have A union B from 0 to 1. I already have a transition there, so I'm going to do a union. So B union A star, should have had room, A union B. Cool. Let's do 0 to F. So Q0 to QF. 0 into 2, I still think is A. Q2 still loops on A, so that's A star again. And then what about 2 to F now? The B star. So I'm going to put B star here. So that is from 0 to F directly. And I already have something there. So I have epsilon union A star, B star. Yeah.
Are you gonna name them?
What's that?
Are you gonna name them?
I should, yeah. So I'm gonna name this whole thing to be R1, and this guy to be alt R2. Nice. Good suggestion. All right, what state to remove next? Any choice? Q1, that seems good to me. Okay, so got a rip Q1, QS still there, QF still there, Q0 still there, and 1's gone. Epsilon in, R2 out, and a B transition on Q0. And I think every other one. Yeah. Okay. So what are all the ways into Q1? Q0. What are all the? Is there a loop on 1? Nope. There's no loop. Ways out of Q1 to go to somewhere else. To 0. So I think I'm going to be only adding one transition on 0 to me. So what is that transition going to be? A loop, but what's going to be on the transition? Well, to get to Q1 is R1, nothing at Q1, and back is A. So I think it's R1A that I'm going to add on to this loop. But I already have a transition there, so I'm going to add B union R1A. Ooh, that was easy. Any choice as to which state to remove next? Yeah, that's the only choice, right? So I'm going to have, so rip Q0, QS, QF. And so what's going to be on this single transition? Well, it's the ways into Q0, there's only one. So epsilon, there it is. Oh, so now I have to self-loop at 0, so what do I put now? Yeah, that whole thing star. Good. So B union R1A star. And then I think to get to QF, I read R2. What's the regular expression that I want? Yeah, the thing on the transition, right? So the regex is B union R1A star R2. That's kind of about it. Okay. Any questions about any of that? Yeah.
How do you decide which states go to QF with the epsilon transition? Like right at the beginning?
Right at the beginning,
Yeah.
I only want one final state.
Okay.
But I need to accept if I am in Q0 or 3, so I just epsilon transition over. It's the ones that were final 4.
Oh.
Yeah, because if I ended up there, I want to accept it somehow anyway, but I only want one final state. So that actually answers a question on quiz 3. Is it true that for any NFA, there is another NFA with the same language with one final state? Yeah, this actually proves it right here. For every old final state of the NFA, make a new final state with the epsilon transitions from the old final states to it. And that actually solves the problem. Cool. Any questions about any of this? Because I can go over more material if anyone has any questions. Yeah.
So like on a test or something, would we need to fill in like what R1 and R2 are in like our final whole answer?
You should like say, okay, R1, hopefully in the R1's here, this is defined right here, R2 is defined right there. Yeah. And as long as you're absolutely clear, you're fine. Any other questions? All right, I'll see you next week.